This episode is brought to you by Peak, the blockchain for real-world applications and home of DePIN. If you think it's time for Web3 to get real, check out their website at peak.network. That's peaq.network. Hello everyone, Daniel from DePIN Hub over here, and today we have Manos, CEO and co-founder of one of the oldest DePIN projects that I know of, called WeatherXM. WeatherXM actually is building the biggest decentralized weather station network, and they've been doing actually for quite some time now. It's been really interesting to follow their growth, and basically the time that I learned about Helium, not much after that I learned about WeatherXM. I remember at the time, I think they already have one station in Lisbon. That was pretty exciting. But anyway, thanks so much for being in the podcast, man. It's a pleasure to have you here. Let's start it. Maybe you introducing yourself and why did you start WeatherXM?
So thanks for the invitation. We definitely started after Helium, so we're not so old, but I think the idea was it actually goes before Helium. So we started. By the way, I'm a computer engineer. So I've studied microelectronics, hardware, and then I did an MSc in internet computing. So I was working as a Java developer for many years, and it was around 2008 that for some weird reason, I picked up this crazy hobby of kite surfing. And that was when I was mostly exposed to the inaccuracies of weather forecasting. So, I had to drive for a few hours to go to this perfect place that the conditions should be ideal for kite surfing, because it's not an easy sport, so you cannot do it anywhere. And I'm talking about Greece, by the way, so I'm from Greece. And I often found myself driving for a few hours, going to a place that there was zero wind. And to my surprise, all the locals there knew that would be the case. And it was just me, the newbie, that I had no idea what was going to happen, because I was just trusting the mobile app in my phone that was giving me a completely wrong forecast for that location. So I had this idea in my mind for like a couple of years, in fact, that, wouldn't it be nice if we had like an infinite number of weather stations and sensors, and obviously I have a tendency to think that the government is not doing a very good job in that department, because they're not very efficient and wasting huge amounts of capital for very little outcome. So it was in 2012 that four of us, that we were colleagues at the time, for computer engineers, that is, we decided to give it a try and experiment with this crazy idea that is called a startup and entrepreneurship and so on. And that was the first ever attempt for what we have today, WeatherXM. So it was, at the time, we called it WeatherX Machina, which in Latin, means weather from the machine, or from the god of the machine. It depends how. It's a Greek drama quote, so in 2012 we gave it a shot. We started pitching this idea of crowdsourced weather observation network, that the humans were actually the sensors, because that was the first step in our ideas at the time. So we can engage with gamification with the users. So we made this mobile app that we were trying to incentivize somehow the user to report weather conditions. And then we wanted to use those reports to evaluate the forecast accuracy of third-party forecasts. So we actually did most of this. So we had a mobile app in Android that had a couple of thousand users that were actually consuming some reports on third-party weather forecast accuracy for their location. That's how old the project is, 2012. But we couldn't monetize on this, and we couldn't convince any investors, so we kind of left it for a while, and we picked it up in 2015. We started our first company. We got into environmental monitoring and weather analytics and industrial IoT solutions, and so we had a lot of customers from that space. But at the same time, we always had this, old idea of doing something like crowdsource weather observations. And it was through many, many iterations and experiments that we landed to what we do today, basically.
Yeah, it's really cool. Just as a side note as well, sometimes I go to Lemnos. My girlfriend actually, she kitesurf, and she's from Bulgaria, and Lemnos is a place that's like have great wind. Last time I was there, I was thinking the same, like, okay, they should have like a WeatherXM station back next to the place where everybody's kite surfing, because then it'll be much more accurate before you go kite surfing, instead of relying on some like app that you don't know actually where the sensors actually are, right? Like one island, for example, Greece has how many islands? Maybe they have 1 or 2 stations in the whole island, depending on how the wind passes by a mountain or something that changes the information. But yeah, I think that's really pretty cool. Can you explain then, you guys started this company to monitor data between like crowdsourced, and then when did you actually get the idea to become like a decentralized weather station through let's say the revolution of DePIN? I guess before it was even called DePIN as well, right?
We were always involved with public goods and commons, and actually I was, I think, as early as 2001, I think, or I was participating in a wireless metropolitan Wi-Fi network here in Athens when broadband and VDSL wasn't very good. So we were just, connecting peer-to-peer nodes, and we were getting fast internet from universities. So so the idea of doing something with the help of the community was always present. And in fact, in 2015, we set up the first LoRaWAN public network here in Greece again, in Athens, as part of the Things network. So I was the Athens initiator. And we also did a few private networks for commercial customers, enterprise customers. And we kind of, we were excited to be part of all these things and to participate on this, but we always felt like there was something missing, that extra incentive that will, boost things and move things faster. So I was paying attention to what was happening with Helium as the American version of the Things network that had the crypto incentive, that eventually got the crypto incentive in its core. And I was impressed by the results. So that's where we got our inspiration from Filecoin and then Helium.
The beginning of WeatherXM and Helium. How does then the WeatherXM incentivize users to actually buy the hardware and deploy them? And where is the best place for people to deploy? And how would you suggest for someone to get started on that? So
first of all, we've designed our own hardware in a way, and I have a lot of our stuff here. So this is the Helium version, by the way, the LoRaWAN all-in-one weather station. So this is our second product. We've done 3 hardware iterations or 3 different types of hardware in the last 2 years, and we have another 3 planning for this year. So we had to build we first of all, we were very opinionated on how a weather station should be, because since 2015, we have deployed a lot of weather stations for our customers, and we were kind of fed up with the state of the hardware industry, and before we actually decided to do the crypto pivot thing, we initially started by making our own hardware. So we went in 2018, we got a small investment from SOSV Hacks, and we went to Shenzhen and we started designing and trying to mass manufacture our own weather station, which was completely different than what you see here. It was this thing. We call this weather pyramid. And so the goal back then and still today is the same. We want to have a low-cost product that is all-in-one, so it's easy to deploy. It's as energy and communication autonomous as possible. So these devices, they all have batteries inside and a small solar panel, and so there's no cables that you need to pull when you deploy the stations outdoor. And if you have the Wi-Fi version, then you need the Wi-Fi gateway that you put inside your house. But the LoRaWAN version and the LTE, which is the latest addition, so this is the gateway, and it connects one of those sensors or some other new sensors that we're planning to launch very soon. And this is the yeah. So this is an LTE 4G GSM gateway that connects to our sensors and sends the data. So all this hardware is as autonomous as it can be, but at the same time, it has a crypto element, a crypto chip that signs the payload, and it has a GPS, a secure GPS linked to the microcontroller. So we have proof of device, proof of location, and proof of cryptographic proofs of weather conditions, essentially, which is very important for the reward mechanism that we have. So nobody can game the system. And so back to your original question. So somebody who's interested to join our network has to purchase one of the compatible weather stations. And in the future, there's going to be other companies producing them too. So somebody gets the station. They have to follow some very strict instructions that we have on how to deploy it. And because if they don't do a good deployment, then the data that are produced are not very useful to the network. And we have created a number of mechanisms to detect that. And we are not going to reward badly deployed weather stations. But assuming that somebody does a good deployment, then every day their data are evaluated, and they share a little bit of the total rewards that go to the network on a daily basis. Regarding the locations, we have created a map. We call this cell modeling. It's in our blog, and we released a research paper for this, and an application, a software open source application that actually does all the calculations on a global scale and tries to answer the question, like, where should we put, if we had an infinite number of stations, where should we put them? And so we come up with a modeling of where should we place, I think 36 million stations, which is obviously a theoretical number that we will never achieve. We have another version of this same thing that answers the question, if you had 1 million stations, where would you put them? That's more realistic because the all-time high of helium in terms of hardware manufactured and almost deployed was around 1 million. So we think it's reasonable to have a similar goal long-term to deploy 1 million weather stations, which will be by far the largest weather network ever conceived by mankind, humankind, not even deployed. So we have created this mechanism that we have a good idea where stations should be placed on Earth, and that is going to be part of the reward mechanism. Right now, the reward mechanism is just looking at the quality of data, and it's not so much incentivizing specific areas. But we have a number of mechanisms in the pipeline that will affect rewards based on area. And the cell modeling is one. The demand for weather data is another one. So it's a dynamic customer thing.
Nice, yeah. PIC is a layer 1 blockchain designed to power DePINs. Why do DePINs choose to build on PIC? It's fast, scalable, low cost offer builders are ready to deploy DePIN SDK, and is multi-chain. So when you build on PIC, you're building for all Web3. PIC is home for the fastest growing DePIN projects, with more than 100,000 vehicles and devices deployed, over a dozen DePINs already building, and the world-leading device manufacturers such as Boss partner with them. Think of building a DePIN? PIC has a grant program for DePIN builders. If you're listening to this, remember, you're early. The PIC network will launch in the first half of 2024. Check out PIC's channels for more details and links in the podcast description. I think that's very important, because when we were talking, I was thinking, what if I just buy a weather station and put it in my office right inside where there's no information? Then that information actually is useless. Then there's a lot of mechanisms that you guys built to do that.
Yeah, so we call this quality of data, and we have open sourced those algorithms as well. And we're using decentralized compute on data technologies like Bacalhau and Tableland, and using versions of our data on Filecoin. So we can do this in a transparent way, and we can be as fair and transparent as we can be to the entire community. However, it's a very tricky thing to do in a completely, permissionless, decentralized manner. So, because the hardware makes things way more difficult if you compare it to a DeFi, crypto project. So not everything is open source yet, and not everything is decentralized. We started with a completely centralized approach, and we are slowly migrating and opening as many parts as we can, open sourcing them, and handling more things to the community and to a DAO that we actually recently launched. So we recently launched the Network Association, WeatherXM Network Association, as a separate entity that is going to be the entity that will take over the DAO in the future.
I really like this approach, to be honest. Like, I always say that building a DePIN with hardware, it's much harder than just like a DeFi protocol that you can get like an open source code, interact with the blockchain, etc. You also have to do that, but then you have the whole hardware aspect and the installation, the physical location, the things that is much harder to predict, and also manufacturing, shipping, allocation. There's a lot of things that you need to do, right? So I think it's really interesting to see how this project they're building this. And like you said, start by being closed source and slowly open source. I think that's the best way to test things. As things work, you start open source so people can have some transparency in what you guys are building. I believe that a lot of projects are trying to follow this, because starting from open source from the beginning can lead to a lot of problems and a lot of slowness. Is that the word in English? Make things much slower, right? Because I think coming back from projects like Helium, because they were so open since the beginning, they were quite slow to do a lot of changes that needed to be done. One thing that I'd like to ask, like, you're going to have, let's say 1 million devices, 1 million weather stations around the world. That gets into the hyperlocal weather data, right? Like, you have a lot of information, a lot of data about small points around the world. How does that benefits agriculture, insurance, energy, and other markets that didn't have before, because you have just a few weather stations per city?
Yeah. So first of all, one has to consider that the actual weather conditions coming from ground stations are used in multiple ways in multiple industries, but the primary use of weather data is in the meteorological industry itself. So weather forecasting is essentially a simulation of Earth's atmosphere, and that simulation is initiated with the latest values from ground weather stations. So the more weather stations you have, the more accurate the data are, the higher the quality of the data is, the more accurate forecasts one can have. Unfortunately, the way that the industry is built today, you have like 10 major meteorological organizations that have the capacity to do those kind of simulations. NOAA is the most famous one in the US, and then you have a European ECWMF, and then you have a few large country ones like Met Office from the UK, or every large Western country usually has a good enough meteorological organization that can do a global or a regional forecast that then all the others are using, and all the byproducts and side products are built around those forecasts. Now, the problem with this approach is that all those forecasts, they are based on very few ground stations that are considered to be like perfect condition and perfect quality of data and so on. So So they are missing a lot of data that are already available by other private networks or are available in our network, and they are not being utilized because of the challenges into clearing out the bad quality data from the good one. I mean, it's reasonable, but at the same time, it's a disadvantage. So traditionally, if somebody buys a weather station and places it, a third-party weather station, not one of our own, but a traditional one, and place it in his house, his forecast is not going to improve. It has nothing to do with the forecast. They will just get actual weather conditions, historical conditions, but the forecast will remain as it was because there's no link, there's no feedback back to the meteorological companies. However, the last few years, because of the improvements in machine learning and decentralized computation and all this, there are quite a few companies that try to spin their own forecasts using machine learning techniques, and those companies are able to consume dirty weather data coming from private networks, and because they use a completely different approach into how they do the forecasts. So those are the kind of partners that would benefit the most from the data we produce in order to improve a forecast. And we are actually doing the same thing ourselves in-house. So we have created our own forecast using similar techniques. So when somebody gets one of our weather stations, we actually produce a custom forecast for that location that is trained on the historical data from the hardware itself. And in the future, we hope that we will compete with those companies. And to be honest, it's not really a problem if we lose and the others are better, because that's part of what we're trying to achieve here. We want to build an ecosystem with a lot of companies utilizing the same data, competing with each other, and the best wins. And if we can compete with open source algorithms and competitions in Kaggle, for example, that we could set up and say and ask everybody to use the data and come up with a better forecast, I think that would be a very good approach for progressing the meteorology with ways that are not being utilized traditionally. So going back to your question, I know I'm over expanding to different directions here, but how can the energy industry or agriculture benefit from this? Well, if they have better forecasts, and if those forecasts are produced by our network or they're produced by third-party companies who can consume our weather data, it doesn't matter, either way, they can optimize their daily operations, and they can optimize their strategy when it comes, for example, in the energy industry to energy trading, and they can overall reduce the resources that they lose because of the weather risk and because of the weather unknowns, basically. I mean, in the agriculture, it's very straightforward. Like if you are a farmer and you want to collect your crops, or you want to seed or fertilize or put pesticides in your field, then the weather conditions are very crucial into those operations. So if it's going to rain, then automatically some of those examples that I said, they cannot be applied, basically. So you have to wait for the rain to end, and if you have a detailed rain forecast, you can see where are the windows of opportunity to deploy to perform those operations. And in the energy industry, because the energy consumption is a very weather sensitive thing, so what usually energy utilities, what they do is they correlate energy with weather conditions, and they use the weather forecasting to create a weather demand forecast or a weather production forecast if we're talking about renewable wind farms, solar farms, and so on. So with a more accurate weather forecast, they can be in a better position to optimize their strategy in buying or selling electricity or producing electricity or handling the energy mix between, if we're talking on a national scale. And then the result is that less energy goes to waste, because in some cases energy is produced and then goes back to earth because nobody consumed it, or in other cases they need to fire up factories last minute and pay extra for the missing energy, or buy it from another country, and so on.
It's impressive how much like having a more accurate weather information data can save you a lot of money and resources of a lot of different companies in different sectors. One thing that I was thinking while you're speaking is that you guys are collecting a lot of information. Also, you got the company started 2008, or the idea at least. How do you see now the past, let's say, year and a half, that the AI models start getting quite popular and quite approachable? Did that change anything on the ways you guys are processing the data? Because I can imagine you'll be processing a lot of data coming from the sensors. If you're gonna get 1 million devices, then it's gonna be like a X is more, 100x more, I don't know, a lot more data, right? How are you gonna process everything, and how would you guys utilize AI for that?
There's like a lot of improvements in many areas at the same time that can benefit our work. And so one is AI, or machine learning as we prefer to call it, but so this gives us the ability, as I mentioned before, to produce a forecast that is not so strict on the actual data source. Obviously, if you put garbage in, you get garbage out, but with machine learning, you can combine a lot of heterogeneous data from multiple sources and ask the computer to find how all this data are interlinked in order to produce a better forecast. So networks like ours have a very, very important value when it comes to creating synthetic machine learning based forecasts. So that's one advancement. And obviously, if I'm sure you've noticed that as AI or ML improves, one of the things that improves is like the efficiency and what kind of hardware they can run at, and the hardware also improves. So, thinking that what ChatGPT has done in the last 2 years was inconceivable a couple of years ago. We would assume that we don't have the CPU power and the storage power to create that model and to run this model, but it seems today it's very normal. So I think similar things will happen with weather forecasting and machine learning. And DeepMind from Google is like one step to this direction. But at the same time, Web3 comes to even accelerate this progress, because now there are many DePIN projects that provide GPUs and computation in general in a more fair and a cost-efficient way, with their own incentives and their own economy. And unfortunately, in the traditional weather industry, the software cannot automatically run in a decentralized style. But in these new approaches, the machine learning approaches, such as the ones that we also follow, it's very easy to break the forecast into very small pieces that are independent from each other, and send every piece as a separate task into a different GPU, and then collect all the pieces back together. So I'm really excited about the possibilities here, and that's one of the reasons that we're using, as I mentioned before, Bacalhau and Filecoin, trying to find ways that we can have those forecasts running in a huge scale.
That's amazing. That's something that I wanted to talk about, because WeatherXM is actually like a DePIN project, one of the first projects to the weather station information. How do you see the DePIN space growing? Because like you said, you guys use, for example, Helium for some sort of the LoRa transmission of data, like Bacalhau for processing, Filecoin for data storage. Now there's a lot of other DePIN projects doing decentralized GPU. Like I think a few episodes ago for the DePIN Hub podcast, I interviewed Nosana, which is a project also doing distributed CPU processing. How do you see this space growing? Because I believe we're just getting started.
I feel the same, because to take advantage of all this technology, there has to be some preparation work has to take place. Like you have to think and design software in a different way. And if you already have some legacy software, or if there's good examples out there of software that can run in a monolithic way, then somebody has to refactor this and break it into smaller pieces. So I think we have not yet witnessed the result of those projects, because it will take some time for the customers of those projects to find ways to utilize those technologies. And I'm talking about ourselves too. It's like I feel very often that we are at least three companies, trapped into the body of one, because we have the hardware and we're doing R&D on hardware. We have weather analytics, and then we have the crypto part, and the crypto expands into many directions at the same time. So the weather analytics part on its own, I think it's worth exploring in combination with the decentralized computation opportunities that we have to produce a better result. A result that it would be very difficult for a traditional company to compete with, basically.
Yeah, that's interesting, and I agree with you. All these things take time, right? And it's at like the bleeding edge of experiment and building decentralized networks, because that's the only way that you can really build massive scale of products. And GPU, for example, is a big topic right now with all the AI. Looking at WeatherXM, what are the biggest challenges you guys have now expanding?
So if you see the network as it has evolved today, we didn't try to control the rollout of our network. So the crypto enthusiasts, as you can imagine, they were the early adopters. I mean, we also have a lot of weather enthusiasts in our community, but so the result of the network today is this thing where a lot of weather stations are deployed in capital cities in the US and in Europe. And the countries that lack weather infrastructure the most are the ones that have the people there have the most challenges in purchasing our hardware because of its price. I mean, our weather stations, they start from $400, and that can be a very high price to pay for somebody in a developing country, for example, who's a farmer. And so there's another problem there in those places, that the communications and it's not just the weather infrastructure that is lacking, it's also the communications infrastructure or the energy infrastructure. So if you think about a farmer in a tropical forest in Mexico, for example, then it's almost impossible to have a weather station deployed there. And that's one of the reasons why we wanted to produce a Helium LoRaWAN based weather station, because there's an advantage there. You can address this problem with if it's possible to expand the wireless infrastructure in a cost efficient way, which is what Helium does with LoRaWAN or with 5G. And and I mean, in the future, I hope that we can do satellite communications as well. But that's a huge challenge today, because then there's no such satellite network that is geared towards sensors. So Starlink is not ideal for that. Yeah.
That's really interesting. But I can imagine, like, the advantage of LoRa, at least, that the signal can go quite far. But if you want to try to do like a weather station in the middle of the forest, you still need that backhaul that needs to go through some internet locally. Or you have like a Starlink, but that's not going to be very likely to be in the middle of the forest, right? That's quite interesting. I guess that goes into like the question that I wanted to ask about the plans that you guys have for the near the short, mid, and long term for WeatherXM, because I think the satellite is a crazy plan, but I can't wait to see it actually happening.
So for this year, 24, we're gonna launch some new iterations of our hardware. We are still working on them, but there's gonna be a solid state sensor that in some cases might be more friendly for the community, because this is the traditional station that we have, and this is a solid state one. So the sensors here are not using mechanical parts, so they're easier to maintain. Essentially, they need almost zero maintenance in relationship to this, but there are some pros and cons. I mean, the ways that these sensors measure precipitation and wind, they are prone to errors. So the quality of data of those sensors might be an issue. We're shipping the 4G hardware in probably next month. We will start shipping it. We have been developing this for quite some time. I'm super excited about the industrial version. So this is a one of its kind, and it's using a completely new technology to sense precipitation. It's using a radar technology, so it's a wireless signal around this sensor that is sensing the drops of water as they fall. Yeah. And this approach has the advantage that it can also sense snow, because traditional weather stations cannot sense snow. And we have, to our surprise, we had quite a few people from our community deploying our stations in places that are covered with snow for a long period of time. Because, coming from Greece, we don't think about snow very often. But so this hardware, it will be ideal for B2B use cases that are in very cold climate, that have snow for many months, and we can actually measure snow precipitation. And also we could potentially measure hail through this technique. There's a lot of training that we need to do in this hardware to be able to detect all this. But that's the beauty of nowadays hardware, is that we through over-the-air firmware upgrades, we can make the hardware smarter, and especially when you have sensors that they're not mechanical, but they are using some kind of indirect phenomena to measure things, then you can improve their accuracy over time with firmware upgrades. Regarding the satellite stuff that I mentioned, I'm actually have been researching on this for quite some time now, for a few years. There are already a couple of companies that they have launched some CubeSats that are LoRa based. So they are trying to create a non-terrestrial LoRa network for sensors. And recently, Narrowband IoT joined the competition. So there are some companies who are launching satellites that can be used with ordinary narrowband IoT, a special version, newer version of it. So we are participating in one of those pilots already. And so it is very likely that in 2025, like next year, we will have a low-cost, all-in-one weather station that will link directly to satellites. So it will be possible to deploy this anywhere on Earth, literally anywhere. And that's one of the things I'm super excited about.
Yeah, definitely. I remember seeing, and I don't remember if it was last year or 2 years ago. It was 2022 in Paris. There was a LoRaWAN conference, and they were demoing the satellite LoRa connectivity, and then super exciting, because then you have connectivity everywhere. I think the usage of LoRa is gonna skyrocket then, right? Because you don't need to worry about the infrastructure. Something that Helium actually made a really good deal of building infrastructure almost everywhere in the world. Like here in Portugal, you have the whole country covered. But then with the satellite, then you can have it easily on the Amazon or places that made of the desert if you want to have some weather station there, because I guess you don't have a lot of data, right, in those locations.
I mean, there are trade-offs, of course, because you need to wait for the satellite to be in proximity. So there could be, it's going to be difficult to have always available satellite to be listening at any place on Earth. It will require a dense network. So what we're going to see next year probably is going to be, one message every half an hour or 1 hour, which is not ideal for the weather industry, but we're getting there. My point is that the helium infrastructure is still needed because it provides a more stable connection and faster bandwidth transfers overall. And LoRa is already very slow, as you know, so moving it to satellite is going to be even worse. But yeah, but it's a start, and it's the only solution if you want to deploy a weather station in the middle of nowhere. So it's a good start because there's no alternative there.
Exactly, it's better than nothing, right? What would you like to tell our listeners where they can learn more about WeatherXM, and what should they do from there? Buy hardware, join the community?
Yeah, so we have a lot of information in our blog, in YouTube, in our channel, in our docs on our website. There's a lot of documentation how to deploy stations because we get those questions all the time. We have a very active Discord community, 10,000 people, and that's also very important for us. And newcomers to the project can find a lot of answers in those places. And we've been on a test net for almost 2 years now, which is unusual for a DePIN project. Usually most projects, they start with the token launch and then build the infrastructure. We decided to do the other way around. We're a little bit old school engineers. So we have been building a lot of things all this time, and we just waited for the token launch as a last step after everything is in place. We're planning to do our token launch in the next couple of weeks, depending on when this video is going to be published. There are many ways to join a project, but the way we prefer is by purchasing one of our weather stations and deploying it in a place that doesn't have a lot of weather data already.
Amazing. Oh, guys, so check WeatherXM website, Discord, and also where to buy the hardware. All the information is going to be in the description of this video or podcast, where depends where you get the information from. Manos, I'd like to really thank you for joining today. I think it was a very interesting, very curious about everything that you guys are building. I'm definitely going to be following everything that's happening with token launch and the satellite devices and everything that's coming up. Thanks so much for listening.
Thank you.
Check @Hotspotty as well on Twitter, DePINHub.io website. Follow us so you can know whenever we send a new episode. And see you around, man. Have a great day and enjoy.
You too. Thanks a lot.